From the deepest reaches of the cosmos, a whisper echoes through the void. It's a tale of a world both familiar and profoundly alien. A world that challenges our very understanding of life and its potential. For millennia, humanity has gazed at the night sky, driven by an insatiable curiosity. We've asked the fundamental question, are we alone in this vast universe? Today, on Next Frontier Science, we embark on a journey to answer that question, or at least, to get tantalizingly close. Imagine a planet, almost a twin to our own Earth in size. It orbits a star, much like our Sun, completing its year in a remarkably similar time frame. At first glance, it seems like a cosmic mirror, a familiar reflection in the endless dark. But this world, known as HD 137,010b, holds a profound secret. It is a frozen realm, an icy desert where temperatures plummet to unimaginable lows. Yet the scientific community is buzzing with an astonishing revelation. There's a 51% chance of life thriving on this frigid exoplanet. How can a frozen world harbor such a significant possibility of life? How can a distant star system hold such a compelling mystery? Prepare yourselves, fellow cosmic explorers, as we unravel the enigma of HD 137,010b. Welcome, curious minds and cosmic adventurers, to Next Frontier Science. This is your dedicated portal to the most groundbreaking discoveries, the deepest cosmic mysteries, and the cutting-edge innovations that are shaping our understanding of the universe. If you're captivated by the allure of the unknown, if you yearn to comprehend our place in this grand cosmic tapestry, and if you're constantly amazed by the sheer power of scientific inquiry, then you've found your community. To ensure you never miss a single one of our expeditions, a single one of our quantum leaps in knowledge, do yourself and the universe a profound favor. Right now, take a moment to click that subscribe button and activate the notification bell. Join our growing community of inquisitive minds, because together we are pushing the boundaries of what is known. We are venturing beyond the current frontiers of science. The story of HD 137,010b began not with a bang, but with a whisper. It was a subtle, almost imperceptible signal, a minuscule dip in the light emanating from a star located an astonishing 146 light-years away. To put that into perspective, a light-year is the distance light travels in one Earth year, approximately 9.46 trillion kilometers. So 146 light-years represents a distance that truly boggles the mind, a scale almost beyond human comprehension. Yet, despite this immense cosmic distance, our instruments detected an event that lasted for a mere 10 hours. This fleeting event was a tiny reduction in the star's brightness, a mere 225 parts per million. This is what astronomers refer to as a transit. To truly grasp the subtlety of this detection, consider this analogy. Imagine a stadium packed with 80,000 enthusiastic fans. Now, try to spot just 20 people in that massive crowd bowing their heads simultaneously. That is the level of precision and sensitivity required to detect such a minute change in a star's light from so far away. What makes this discovery even more remarkable is that it was not solely the work of professional astronomers with multi-million-dollar telescopes. It was, in part, brought to light by the dedication of citizen scientists participating in the Planet Hunters project. Planet Hunters is an initiative that invites the public to help analyze real astronomical data, specifically light curves from stars, to search for the telltale dips that indicate transiting exoplanets. These ordinary individuals, just like you and me, meticulously sift through vast amounts of data, contributing to cutting-edge astronomical research. This highlights the incredible power of collaborative science and how human curiosity, when channeled collectively, can lead to profound breakthroughs. The data, initially collected in 2017, meticulously revealed a planet with an orbital period of approximately 355 days. This is strikingly similar to Earth's own orbital period around the Sun. In its celestial dance, this planet, HD 137,010b, appeared to be a cosmic doppelganger of our home world. However, this is where the narrative of HD 137,010b takes a truly intriguing turn. Despite its Earth-like size and orbital duration, this is no verdant paradise. Far from it. In fact, HD 137,010b orbits a star that is significantly smaller and considerably cooler than our Sun. This fundamental difference has profound implications for the planet's environment. It means that HD 137,010b receives only about 29% of the solar radiation that our Earth basks in. Without the insulating embrace of an atmosphere, the equilibrium temperature of this distant world would plummet to an astonishing -85 degrees Celsius. Visualize that, a world perpetually locked in an icy grip, a frozen wasteland where liquid water, a prerequisite for life as we understand it, would be solidified into an unyielding crust. It's a desolate, frigid expanse, a testament to the harsh realities of the cosmos. Imagine this. You stand on the surface of HD 137,010b. The ground beneath your feet is an endless, jagged expanse of ice, stretching to a horizon shrouded in perpetual twilight. The air is thin, biting cold, and the distant host star, a pale ember in the inky blackness, casts long, ghostly shadows across the frozen landscape. There are no familiar sounds of wind rustling through trees, no chirping of birds, no gentle lapping of waves. Only the profound silence of a world utterly devoid of warmth and conventional life. It's a scene of stark, brutal beauty, yet it compels us to ask, could there truly be any hope for life in such an unforgiving environment? And this, my friends, is precisely where the marvels of science continue to astound us. The glimmer of hope for life on HD 137,010b resides in a truly fascinating possibility. What if this seemingly barren world possesses a dense atmosphere, rich in carbon dioxide? Yes, the very same gas that here on Earth contributes to the greenhouse effect could be the unexpected key to habitability on HD 137,010b. If HD 137010b were enveloped by such an atmosphere, the greenhouse effect would be so potent, so efficient at trapping heat, that the surface temperature could potentially rise to approximately +5 degrees Celsius. This seemingly small increase is, in fact, monumental. It is precisely the temperature range required for liquid water to exist on the planet's surface or beneath its icy crust. And as we know, wherever liquid water is found, the potential for life in some form dramatically increases. Underneath that thick, insulating blanket of atmosphere, scientists hypothesize that vast subglacial oceans could churn with unseen currents, or perhaps saline lakes, warmed by internal geological activity, might harbor adapted life forms. We're not necessarily envisioning green-skinned aliens or complex ecosystems. Instead, picture hardy microorganisms, extremophile bacteria, thriving in conditions that would be utterly unthinkable for terrestrial life. It is this profound possibility, this delicate balance of extreme conditions and potential atmospheric shielding, that gives us the intriguing 51% chance of life. This extraordinary potential is precisely why HD 137,010b has rapidly ascended to become a priority target for the James Webb Space Telescope. The Webb, with its unparalleled infrared capabilities, is our most advanced instrument for probing the atmospheres of distant exoplanets. It possesses the unique ability to analyze the chemical composition of HD 137,010b's atmosphere, searching for biosignatures. These biosignatures are the telltale chemical signals that could indicate the presence of biological processes, the faint fingerprints of life itself. The James Webb Telescope holds the key to unlocking the answers we so desperately seek, to confirming or refuting this tantalizing possibility. However, it is crucial to maintain a realistic perspective. Science, by its very nature, is a continuous process of discovery, refinement, and often the unveiling of new complexities. The estimate of a 51% chance of life is not a definitive declaration. It is a probability meticulously calculated based on sophisticated models and informed hypotheses. It reflects the immense potential of this world, but it is not, by any means, a certainty. To definitively confirm the presence of a dense carbon dioxide atmosphere, and even more so, the existence of life, will require extensive further observations and in-depth analysis. The James Webb will undoubtedly provide invaluable data, pushing the boundaries of our knowledge. But the journey of discovery is often a long and arduous one. The very definition of habitability itself presents a significant challenge. A planet might possess liquid water, yet be relentlessly bombarded by lethal radiation, or suffer from extreme geological instability. The universe, in its boundless expanse, is replete with an astonishing array of variables, each capable of shaping a world's destiny. Yet, this inherent complexity is precisely the beauty of scientific endeavor. It is the relentless pursuit of answers, the unwavering willingness to question established paradigms, to rigorously test hypotheses, and to continuously refine our theories. HD 137,010b stands as a powerful, resonant reminder that the cosmos is teeming with wonders, patiently awaiting our discovery. It whispers of the profound possibility that life, in its myriad and astonishing forms, may be flourishing in places we can barely conceive. The story of HD 137,010b is, in essence, the story of our own innate curiosity. It serves as irrefutable proof that even when confronted by a universe that is both vast and often seemingly hostile, the enduring hope of encountering other worlds, and perhaps even other forms of life, continues to propel us forward. Every new discovery, every new piece of data, represents another pivotal chapter in a much grander saga. It is the epic saga of humanity's relentless exploration of its cosmic home, a narrative that continues to unfold with each passing moment. And it is this magnificent saga that we, together, are meticulously constructing here at Next Frontier Science. If you have felt a spark of inspiration, if your mind has been expanded by these revelations, and if your curiosity has been profoundly piqued, then you are an integral part of this extraordinary journey. Do not hesitate to subscribe to our channel, activate that notification bell, and share this video with all your friends, family, and fellow enthusiasts who also gaze at the stars and dare to dream of what lies beyond. Because here, at Next Frontier Science, the next frontier of scientific understanding is not just a concept, it is our unwavering destination. Until our next groundbreaking discovery, keep looking up and keep questioning the universe.